Number 5, so we've got this equation and we want to fill out all this information and then just graph it. So this information does not have to be filled out in order. So take a look at the equation and think about what's the first thing that you know, what's the easiest thing to pull out. Well, if you recognize that this is in vertex form, just based on the way it's written, you recognize it's in vertex form, then you know that this and this number are the vertex. Well, or they're related to the vertex, they're not exactly the vertex. So remember that when this is inside of parentheses, this number right here goes with the x-coordinate, so it's going to be the x-coordinate of the vertex, but remember it's going to have the opposite sign. So the vertex x-coordinate is a positive 2, and then this out here, it's sort of out here with y, and so this number is going to go with the y-coordinate of the vertex, and it is not inside of parentheses, it is going to keep the same sign that it currently has, so it is going to be a negative 3. Okay, so then look at the other things that you need to know. The axis of symmetry goes directly through the vertex, right? So you're going to have, your parabola like this, and then the axis of symmetry is going to go straight through the middle. And so if you know the vertex, you actually also know the axis of symmetry. Now the axis of symmetry is a vertical line. So equations of vertical lines are just x equals whatever it's going through. So see, you can see no matter what your y value is, your y's can go up to infinity, your y's can go down to negative infinity, but your x value just stays right on whatever that point is. So the axis of symmetry here is simply x equals 2. See how it's related to the vertex. Okay, which direction is this going to open? Well, we don't actually know just because we know these two things. It could be opening this way or it could be opening this way. If you recall, the part of the equation that explains or that determines whether it's opening up or down would be the number that's right in front of here. We usually give it the letter A when we're writing basic forms. But anything that's right out here is going to determine whether it's opening up or down. If this number is positive, it opens up. If this number is negative, it opens down. Well, we don't see anything there at all, which means that there's a ninja 1. You could draw in a 1 there, and it is a positive 1. If it were a negative 1, we would just see a negative sign. But if it's a positive 1, that means that this is opening up. Okay, so let's go ahead and graph the things that we have. So 2, negative 3, and we know the axis of symmetry goes through right here. And then we know that it's going to be opening up. Well, this number right here, not only does it tell me if it's opening up or down, it also tells me if there's been a vertical stretch or a compression. And since it's a 1, and when you multiply things by 1, you don't change their magnitude, this has had no vertical stretch or compression. So the very basic quadratic function, if you're here, then to go to any point on either side, you just go over 1 and up 1. And then if you want to go to another point, you go over 2 and up 4. Now I'm not pulling these numbers out randomly. This is because when you're doing y equals x squared, if you square 1, if you go over 1 on x, you have to go up 1 on y. And if you go over 2 on x, that means that you're going up 4 on y. So when I go over 1, I go up 1. When I go over 2, I go up 4. If I were to go over 3, 3 squared is 9, I would go up 9. If I were to go over 4, 4 squared is 16, I would go up 16. So this is the quadratic graph. And so we've got two other points here. This is the point 0, 1, and this is the point 4, 1. So I'm going to put those points here as my two other points. So the only thing I'm missing are the domain and range. Domain, how far on the negative x can it go, and how far on the positive x can it go. So it's going to the left forever, and it's going to the right forever. So my domain is negative infinity to positive infinity, parentheses around infinity, because you can't actually get there. And my range, how far up and down can it go? So it can go down right to here. We see this dotted line going down, but that's just a symmetric line. It's not actually part of the graph. It's just drawn in to kind of help you see the symmetry. So this is the lowest point on my graph, and that has a y value of negative 3. So the lower bound of my range is negative 3, and I actually touch that point, so I put a bracket there instead of parentheses, and then I can go up to infinity.